So hello, everybody. Welcome to our virtual talk about underground natural gas storage. My name is Christina Sidorico, and I am the Educational Program Coordinator for the Oil Museum of Canada National Historic Site. I'll be moderating this presentation this evening, and I'm going to begin with a little bit of background about using Zoom before we get started. For those that are unfamiliar or this is one of the first times, you can use the chat box to talk with others in the webinar, attendees, and make your own comments. It will be monitored and it is being recorded. If you want to send a message to the whole group, you have to send and select all attendees. Otherwise, it'll just come to Jug, who is our panelist, or myself, who is the host. To get the chat started, you are welcome to share where you're from. We are also going to be using the chat box and the Q&A. The Q&A section is where if you have specific questions for the end of the presentation for Jug or myself, you put them in there so that we know that those are questions that you would like answered, so that we can save those for the end and make sure that we address them. I'll be recording the presentation and you will receive a link in an email in the next day or two that you can share again, and we will be sharing it on our YouTube channel. I want to take a moment to introduce the museum before we get into the presentation. The Oil Museum is a National Designated Heritage Site situated in the historical oil fields located in Ontario's first designated industrial heritage district, and it recognized under the Ontario Heritage Act. The museum preserves and interprets the important history of Lambton's innovation and global contributions to the pioneering oil industry. The main exhibition center was opened in 1960 and houses over 9,000 artifacts, which interpret the history and the influence of Lambton's proud oil heritage. In 2001, we started a renovation project that closed our doors to the public for a year, and we are now happily reopened and welcoming visitors back to our site. The doors of the museum are open, and we can't wait to see you. Today, I'm very excited to welcome Jug Manocha. Jug has been involved in the oil and gas industry for over 40 years, from his early beginnings of drilling wells in Cold Lake to designing and operating cavern storage facilities in Sarnia to provide engineering services to the Ontario government for various oil, gas initiatives and projects. This includes leading a couple hundred wells, plugging them, stopping the disposal of oil field brine into the creeks of Lambton County, particularly the Black Creek, and providing a leading role in the development of provincial operating standards and providing emergency preparations and response to the petroleum wells, leading the incident investigation for oil and gas related incidences and providing expertise on petroleum wells, and establishing Canadian standards on the storage of hydrocarbons in underground formations, including reservoirs and salt cavern storage, and more recently for well design and well integrity. He has published many papers in underground well storage and well integrity, and he has been recognized with an Ontario Amethyst Award for plugging an extremely hazardous well. Also recognized with an Award of Merit from the Ontario Petroleum Institute for training and education, and an Award of Merit from the Canadian Standards Association for his role in standards development. Jug has a huge list of accomplishments, and we are hugely honored to have him here. He has been a friend of the museum for many years. I have followed him when he comes for visits or if I'm seeing him at conference, and he's been a wealth of information, and I am very happy to have him here. Jug is also part of the facilities, hoping to bring Solution Mining Research Institute and its members to visit the site in 2023, which we are excited to welcome that group when we finally get some dates. So I'm going to turn it over to Jug. Feel free to share your screen and we'll get started. And it's now over to our friend, Jug Manocha.
Thank you, Christina. And thank you to the Oil Springs and to the National Oil Museum of Canada for inviting me. And I'd like to thank you for joining us today. Okay, that was too much of an introduction, but anyway, let's carry on. And what I'm going to try to do is try to talk about the historical oil fields And I'll try to talk about the natural gas storage and salt caverns all together in one presentation. Now, recognize it's a very complex topic. It's a very complex industry. You normally have geologists, drilling, reservoir engineers, rock mechanics, risk assessment people, bunch of qualified experts. So, you know, I'm very humbled, but it's a very complex industry. But I'm going to see if I can make it a little bit of an interesting presentation so people can get a flavor for what it is and how it affects people in Ontario. Now, I know some of you have way more expertise than I do in some of this. Some of you may have expertise on one type of storage, and many of you are hearing about the storage in Lambton County for the first time. So let's start the journey. I'll do the best that I can. And if you have further comments, or if you need to contact me with any other questions, I voluntarily gave my email there so you can contact me. And I'll be happy to take some of those questions as well through the presentation. I love this picture only because this is a real operating historical oil field. You know, you could go back in time. And in fact, I've got a Chinese delegation here. They were just so impressed. But this is an operating field at the Fairbanks Oil, very close to the museum. Some of you may not know the history of the museum, but I'm going to promote it a little bit. Right on this left-hand side here, these are what they call gum beds. This is how the oil was actually seeping to the ground in the oil springs area. And that kind of led into the first commercial oil well being drilled in the site back in 1858. From there, there's a fairly big history in terms of how people started making gasoline, kerosene. We got into the chemical plants and refineries and how we actually got into making some of those products. And many of these products actually, ethylene, propylene, butane, some of these basic components actually went through storage. So what I'll do is I'll summarize my presentation right up front. I'll give you an overview of the hydrocarbon storage in Lambton County. We're going to be looking at the natural gas storage in reservoirs. We're going to be looking at storage in salt caverns. This is a very significant industry that for providing a reliable natural gas to the people of Ontario. I'll talk about the safety, environmental, and regulatory framework. And I've already had a couple of people ask me questions on this, so I'll spend a little bit of time with that. I'll try to bring in a little bit of the oil springs history and some of the opportunities that we see based on the geology, the location, and the expertise in the Lambton County. So in summary, the natural gas and hydrocarbon storage is provincially significant. What does that mean? Well, the province has designated natural gas storage areas. This is under the reservoir storage. These are significant as about 50% or more of the natural gas in the wintertime is actually coming from the storage in the Lambton County. There are 35 designated natural gas storage pools, and 32 of them are in Lambton County. We talked about the salt cavern storage. This is something most people aren't familiar with, but these are typically associated with some of the petrochemical refineries and plants. These are again regulated by the Oil, Gas, Salt Resources Act. There's 70 of them in the province, with 62 of them in Lambton County. They typically store ethane, ethylene, propane, butane, NGLs, liquefied petroleum gases. These are stored in very large volumes at a very high pressures. And I'll talk a little bit about why the geology is important, what the safety considerations are, what some of the environmental protection features are. So that basically is a summary. If you don't want to watch the rest of the presentation, please feel free to leave, because I'll come back to this at the end, and hopefully we'll have a little bit of a journey and enjoy kind of sharing some of the lessons along the way. Now, Lambton County really hasn't changed much. This is the map of Lambton County from back in 1885. What I really want you to pay attention to is This is the oil springs. This is where the historical oil museum is. Petrolia is here, and Sarnia is here. Now, being in the oil and gas industry, we generally have this big, what we call a pool, pipelines, and a map. But I'm just trying to orient where Lambton County is in relationship to Niagara Falls, Lake Erie. The red areas actually show the natural gas reservoirs. The green areas show where the oil is produced. And these little dots in here, blue, are where the designated storage areas are. I'll show a lot more detail on this as I go through the presentation. Now, just so that we get on the same wavelength there are two main types of underground storage in Lambton County. One is what we call the reservoir storage. This is the reservoirs that actually produced natural gas initially. And we can actually use those natural gas reservoirs to store natural gas. So essentially, these reservoirs had natural gas in it for a long time. It was extracted. It can be reinjected back in. Depending on the reservoir and the characteristics, it really determines what you can do with it. The other type of storage is what we call the salt cavern storage. This is a storage into a salt formation that is actually mined. We actually solution mine these, and I'll show you how we do that. So again, most of the natural gas storage industry, you will typically see a wellhead at the surface. But what's really more interesting for me as an engineer is what's actually down beneath. Quite often the well will be here, but you may be tapping a reservoir some distance away from where the well is, or you may have multiple wells going into the same reservoir to increase the capacities of flow rates. Similarly for the salt caverns, this is all you'll see at the surface. And essentially this is the well located right here. But this is very small. Now, if you take a look at this picture, this well can store probably about 500 of these, what these 500 of these bullets can store. So it actually gives you a very, very high volume, and it actually lets you to store at fairly high pressures. So again, I just want to make sure we understand the two concepts. A reservoir is a naturally occurring formation where people have taken, which is full of natural gas. It's either been emptied a little bit or depleted. It can be reused to store natural gas. So that's what we call the reservoir storage. The salt cavern storage is in a salt cavern that has been constructed specifically for that purpose. So we've got funny names there, but this is called what we call the B salt, and I'll show you that more in detail. And typically these reservoir reefs occur naturally into the A2 carbonates. Okay, I think everybody recognizes the structure in the middle. This is CN Tower, and interestingly enough, both the salt cavern people and the reservoir people have used this as a scale. So when you're looking at it, typically the salt cavern storage is at about 500 to 600 meters below the surface. And similarly for the reservoir storage as well. So you can see that here, and this is typically a reservoir that is used for storage. So it just gives us a good measure about how deep we actually are. This is the All Springs Museum, or the Museum of Canada, the Oil Museum of Canada. I'll get this right yet. Anyway, they actually have a really nice display there about the geology. And they actually show you, the different types of rocks. Like this would be a typical cavern mined out of here. It actually shows you that this would probably be a location where the natural gas storage reefs are. And they actually have some samples, what we call the cores, of what the formations actually look like in the subsurface. They actually have all of this here. So again, you don't see most of this stuff on the ground. You only see this. But when we talk about natural gas storage, we'll talk a little bit about the geology here. It actually occurs in what we call the A2 evaporites. So this is like a cross section that we use from geological purposes. And these are the different names for formations as you go down. And when you have these, what we call pinnacle reefs, okay, those are the reservoirs that are predominantly used for storage in Lambton County. These are usually like a pinnacle reef. They have in order for them not to leak anything, they actually have what we call a cap rock above it, and they have some sealing components around it. Those are very important, even in the beginning, when natural gas was actually found there. That's what retained the natural gas in the first place, or it would have leaked out. Right? So those reservoirs actually have some really good parameters if they, if they have gas in them. Now, typically, this is what we call the pinnacle reefs. So they don't occur everywhere. They occur in some locations, and sometimes when they occur, they may not have the natural gas in it. They may have become salt plugged, or they may not be suitable as containers for natural gas. But there are some that are suitable. So this would be looking in the subsurface at a depth of about 500 to 600 meters. This is the part of the bigger complex, if you will. There's a pinnacle reef belt that goes all the way around here to Michigan. Now, this is probably the ideal area in Ontario here. When you go further north, the reefs are not as good. They're smaller. They may have become a little bit more salt plugged. But this is the ideal area in the Lambton County where we do find some really good quality reefs for storage. So when we have the storage reef, there's a number of wells that go into each reservoir, and these are used for injection and also for withdrawal of gas. You'll quite often have what we call observation wells. They observe the pressure, the temperatures, the flow rates. We really want to make sure we control and we know exactly what's going on with the storage. There's monitoring at the surface. We also want to know what's going on in the subsurface as well. This is a little bit closer look at the designated natural gas storage areas in Lambton County. These are the ones in blue. So there are 32 designated natural gas storage areas in here. These areas are designated by the Ontario Energy Board, and people cannot drill on top of them or try to steal gas from close by. So it's really considered as significant for the province. There are 244 injection wells, 88 observation wells. And these reefs range quite a bit in size, anywhere from 0.5 BCF to 37.7 BCF, with a total capacity of about 280 BCF. Now with the reefs, we can get very technical with this. In order for you to store gas, the gas has to flow across in a reef because it has to have permeability, it has to have porosity. You have to be able to deliver gas in and out of there. And it has to be contained. So that's where the cap rock really comes in handy. I'm not going to go into too much into detail on this. This is a full 2-day presentation just to talk about the Don Hub. But if you looked in here, there are a number of these designated storage areas. For example, the Oil Springs East. That feeds into the, all these systems feed in together to a common Don Hub. There's also a big facility. It's called the Coronado-Tecumseh Gas Storage Facility. They actually do some compression here as well. There are compression stations involved with some of these things, but the main hub is at Don. And in here, a lot of the different pipelines come in. There's 10 major pipelines. There's a lot of different people that buy gas and sell gas through this hub as well. So this is a very central part for the North American natural gas market. You can find a lot more information on the internet, and I'd encourage you to do that. Okay, so that was a reservoir storage. Let me talk now about the solution mine caverns. And again, as I've indicated, they're part of a plant. But what I want you to do is notice in here, what we call the brine ponds. these are very important for the cavern storage. And we use what we call a brine displacement method. I'll talk a little bit more about that. And this is what you normally see at the surface. Again, looking at the geology, in the Sarnia area, predominantly in the B-salt. There's a couple of exceptions, but B-salt is the formation that's used for the storage. Now the B-salt, there's a number of different stratigraphic labels on salt, but the B-salt actually goes right from Godrich through the Sarnia to the Windsor. Typically it's 500 to 700 meters in depth. It's about 90 meters thick. So that gives you some idea about how big you can develop your caverns. And that's the formation that most of the caverns in Sarnia use for storage. Now, when we're talking about salt caverns, they aren't like table salt, but actually it comes from there. This is what it might look like. These are the mines in Windsor, Godrich. They actually mine out the salt that you see used for roads. But these are the formations. And one thing about salt is that it doesn't react with the hydrocarbons. It's very inert. And the other thing that you can see in here, you can make the structures big. So you can have the structures so that you have structure stability when you design a solution mine cavern. Now I'm going to take, developing a cavern takes years and a lot of expertise in that, but we're going to condense it down to like 30 seconds. So just bear with me. And typically when you're developing a solution mine cavern, you drill a well into the salt formation. You would take fresh water and basically take out concentrated brine. Okay. Essentially what you do again is you would increase the volume of the cavern as you wash out more brine. And eventually you'd get a shape that starts to look something like this. So you now have a container that is made in the salt that you can use for storage, but it's full of brine, right? It's full of water. And once you get this container to the sizes that you want, but there's a lot of advanced techniques and several $1 million spent to get to this stage, but you end up with what we call an underground salt cavern that could be used for storage. Now I'm trying to keep it simple, folks, and this is like a typical cavern storage, if you will, where we have stored hydrocarbon. And recall the brine ponds? Well, the brine ponds come in handy when we want to get some product. We push the brine into the cavern. The brine pushes up the hydrocarbon, and the hydrocarbon goes to the pipeline. Similarly, when we want to store hydrocarbon, we put the hydrocarbon into the cavern. The brine comes out of here, it goes to the pond. Okay. Now, brine is a significantly more dense material than the hydrocarbons that are being stored. So what happens at this depth of 500 to 600 meters, you can store hydrocarbons anywhere from 500 to 1,000 pounds of pressure. So that's a big advantage of this underground storage. And again, this is all you'd see at the surface, but there's a lot of instrumentation, control systems, shutdown systems that are involved in monitoring. So just to give you an idea, there are about 70 caverns in Ontario storing liquefied petroleum gases, natural gas liquids, ethane, ethylene, propylene, butane. They're typically at 600, 900 pounds pressure, typically depths of 500 to 800 meters. In the Sarnia area or the Lambton County, we have a number of companies that operate these storage caverns. There are 62 caverns. Some of these caverns have a single entry, some of them have dual entry. But I think it's just important to know that there's two types of storage: salt cavern storage and reservoir storage. The safety is paramount to everybody. Like, this is something that why storing the underground, and there's a number of advantages to doing that. Number one, when you're storing in the subsurface, You're not exposed to oxygen. So you can basically store, and you're storing in containers that are not subjected to weather. The temperatures are very constant. And they're proven storage containers. You test them. There are requirements to test these containers. There's requirements to monitor exactly what's going on. We want to make sure that nothing leaks out, both from an environmental point of view, and you don't want to lose any product either. This is expensive products. They're being stored at very high pressures, but you want to make sure everything is done in an environmentally safe manner. What these caverns allow to do, and the underground storage, because of the depth, most of them are in very secure locations. The storage also provides a security supply, like in terms of if there's a pipeline failure in Ontario that's supplying the gas from Alberta, you can actually go back to storage and it can actually supply most of Ontario directly from the storage in Lambton County. What I really try to do is look at a reasonable, practical approach to these things. How can it be functional? What do we need to do? What do we need to do to make sure it's safe? Now, one of the things that people probably don't know is that the natural gas has been stored in the Lambton County for 80 years. The cavern storage actually started there 70 years ago. And most people have never heard of this, and probably that's a good thing because it's important that these things are kept safe. There's some regulatory overview protocols that really make a difference as well in terms of making sure that people follow the rules and the requirements. The Z341 standard is a national standard for storage of hydrocarbons in underground formations. For the reservoirs, they have to follow the Oil, Gas, Salt Resources Act, but it's actually a matter that's referred to the Ontario Energy Board. So Ontario Energy Board actually regulates the designated storage areas. Quite often it regulates the prices that people charge for gas and for storage. And if this designated storage area, in order to develop it, they may have to deal with people who own the mineral rights, or they may have to deal with people who own the farms where the storage is located. So if you happen to be lucky enough to have this pinnacle reef that's suitable for storage, certainly in Lambton County, you could be a lucky person and get compensated for that type of thing. And people do get compensated on an annual basis as well by some of the utility companies. So generally, the reservoir storage is operated by Enbridge or utility companies. With the salt cavern, we're storing typically ethylene, propylene, butane, those type of petrochemicals. These are generally owned by the petrochemical refineries. It is again subject to the Oil and Gas Salt Resources Act and also to the Z341 standards. Talk briefly about what these standards are. And I've been, as you mentioned in the introduction, I was on the founding group for those standards, a long time ago, and we're now at the 7th edition. I'm still a member, and I find it fascinating. This is something that I'm passionate about, and it's always sort of in the idea that what can we learn from other people? How can we make things better? And what are the right things to do? So the CSA standard covers everything from the initial concept to the design, to the maintenance, what kind of risk assessment needs to be done, what kind of emergency procedures need to be placed. This actually gets into a lot of specifics as to what's required for the storage. Now, most of the companies far exceed these are minimum requirements. Most of the companies far exceed these, but these are put into place so that they are the minimum requirements for operating storage facilities. Okay, again, I don't want to get too technical, but this is the kind of stuff that we deal with when we get to the storage. How do you design your casings, surface casing? These are the casings that you use to protect the freshwater aquifer, to protect what's inside. How many casings do you need? What are the design for that? What is the design life expectancies? How do you know they're good? And quite often when they're installed, we run kind of cement bond logs, we run verti logs. These are logs that we run to make sure that the casing is good, everything is the way it's supposed to be. And These are run every 5 to 10 years after that to make sure that nothing has happened. So we check the integrity of all the storage as a requirement. Again, keeping it simple, but recognize the fact that we're in a complex industry. And typically on the salt cavern storage, for instance, you will see this kind of an instrumentation where you want to know what the flow rates are, what the temperatures are. If anything fails, you want everything to fail safe, and these emergency shutdown valves, they go closed. So while this might look complicated, and I really don't want to get into any details on this, but I want you to know that it's there, and people do monitor it, and these had to be tested, etc. So these are a lot of safeguards that are built into the storage industry. We do have some fun sometimes. So this was one of our field trips with our technical committee, the Z341 technical committee. The committee develops the standards, but it's made up with people who are operating facilities, outside consultants, general interest groups, and the regulators. So you want to get standards that are practical, that protect the public, that are also reasonable to implement. Now, this committee actually came out, and Johnny Fairbanks gave us a tour of his field, and certainly enlightened us with a lot of his knowledge and his experience. And this is a group from all across Canada. So the CSA is actually made up of people. I know one of the persons on the call from BC. You know, we have representation from many different jurisdictions and also from many different operators. This Charlie overlooking his field here, one of the original wells back here. Many of you have never seen a lot of this stuff. These are what they call the jerker rod lines. This is a transmission kind of thing to change directions when you're going from one to the other. So you can actually have one pumping station that is pumping many wells. And, you know, believe it or not, this is actually an operating well in this area. Two things about it. One is, yes, it's producing oil. The second thing is, it is simple, but grass is growing all around it. You know, some of these wells actually have wooden casings, so these go way back. Some of these have been operating for more than 100 years. Picture of the Oil Museum of Canada. Amazing place to visit. You'll actually get to learn a lot from the history back in 1858 in terms of how the drilling was done, everything from jumping up and down to some of these derricks. They actually have a lot of really nice videos and pictures and displays. I certainly recommend people visit it. I kind of like this one here. This is something you had to go back into the basement and look in the records. But this was a postcard from back in 1906, torpedoing a well near Petrolia. This was considered a sign of success back then. And it still probably is. I found this interesting as well. This is how they used to transport oil. This is from Petrolia, and you know, they have these containers being pulled on the horse buggies. And in here, what's really interesting is when you look at the horses sort of pulling this wagon full of oil, it's built on a plank road. Okay, this is significant, and this is how the oil was actually taken from Petrolia Oil Springs to Sarnia for shipment. So this is the map showing the plank road as of 1859. Now, actually, there's a new road that actually exists there today, but this is a lot of the beginnings of how the oil actually started, a lot of the interesting history, how some of this stuff actually came to be in Sarnia. You know, you could argue the fact that many of these refineries and even this rubber plant ended up in Sarnia because of the history of oil springs and Petrolia. The other thing that you might find fascinating, and that's what I'm trying to do here, folks, is combine the three different things, you know, the salt cavern storage, the reservoir storage, and a little bit about the museum as well. So when you start looking at this, the importance of the oil springs, you look at this, and there's a lot of the discoveries in Alberta, Iraq, were based on the findings or lessons learned in oil springs. They brought their skills, techniques with them to over 50 countries or 80 countries on 5 continents. According to the oil springs, the global industry was launched from oil springs. Now, for those people that are in the drilling business, one of the things that we go back into history, and they used to use a lot of cable tool drills here, drilling rigs. And these are some of the tools that they use when they got into problems, that they couldn't find some casing, they couldn't find some beds. There were many problem fixers. And these are the actual tools, replica models of what was used to drill wells. The other thing I find really fascinating is the sculptures that they've created there. This is Leo Rennie, an engineer. He held 3,000 patents, from drilling machinery to bathtub toys. So you kind of I just find that fascinating, because we're also going to see this. One of the other interesting displays is they talk about the natural gas storage. And this is a little shed open to the students, open to the public, but it talks about, one of the slides in there actually talks about how the first storage was done by Dr. Charles Evans. He actually proposed the first Pinnacle Reef storage in the Don Hub in October 28, 1942. So that was almost 80 years ago. So that was kind of the beginning of how this whole thing started. This is a typical compressor that they would have used some time ago. And some versions of this actually exist now. This is what they would use to compress the gas to inject it into the storage reservoirs. This is like a display model of a gas storage wellhead. But this is what you would use to inject gas or withdraw gas from here. And it would go in here and go to a pipeline to a compressor station. Now, if you take a drive just down the road, and I'm not sure if you're supposed to do this or not, but I did take a drive just down the road and went to this compressor station on Oil Springs East. So you can see there's some compressors inside this building. There's some pipelines that come in, and gas actually gets compressed, either sent into the reservoirs or into the pipeline systems. So this is the field, the Oil Springs East field. You can see wells here, wells here, wells here. What you also see is everything is going around them. So this is like an integrated part of their storage system, but they also work with the farmers in the storage end. And this is a close-up of one of the Oil Springs East wells. You can see there's emergency valves on them. There's also solar panels that kind of give you an instrumentation back in here that goes back to a control room so you can see what's happening on the well. So I think there are some opportunities. When you look at the geology, when you look at how much footprint we're actually using, when you look at the experience, the infrastructure, I think there's opportunities to do more. I think, first of all, make sure what we're doing is good, but then also perhaps developing additional storage and looking for additional reefs. And some of the activities that have happened is they've actually increased the pressure in some of the reefs above what they found it at. And again, that's based on a lot of rock mechanics, reservoir engineering, and just trying to make sure everything is sound. The other thing that's happening on a national, international scale is people are looking at more projects that involve, compressed air energy storage. That's when you would take something like a windmill or a solar farm that creates electricity that's not needed. You would compress the air, store it in the cavern, and then when you needed more energy, you would take it out and generate electricity. There's also some push towards a little bit more greener hydrogen storage, both in the reservoirs and also in the caverns. Again, these are things that are under consideration, but there's potential to develop this type of storage down the road. So as I said, this is a summary. Natural gas hydrocarbon storage are provincially significant, and they're recognized as that by the Ontario Energy Board. We also know that we provide a significant amount of security and a significant player in the overall business of storage. So again, 32 reservoir storage pools in Lambton County, and they provide up to 50% or more of the peak winter gas demand. They're considered paramount, and they've been designated as such. The salt cavern storage is very integral to the operations for the petrochemical companies. That allows them to store products such as ethylene, propylene, butane. These products are primary petrochemicals that are combined and used for other things. And this is the safest way to store it. A lot of the safety environmental protection is covered by the Z341, the CSA Z341 standard, and it's overseen by the regulators. So Lambton County, based on the historical role, also on the storage role, has played a significant role right from the historical in terms of what to do with the gum beds, what to do with the oil, to the actual storage of natural gas. And I think there's opportunities to develop further some of the storage in caverns. So I think that kind of concludes my presentation. If anybody has any questions, I can certainly try to address it.
Well, we do have quite a number of questions, and some of them are just clarifications, such as, what do you mean by BCF?
Okay, that's good. Good question. Very good question. Okay, just let me do the acknowledgements first, and I'll answer all those questions. Just to thank everybody that's kind of helped me to put this presentation together. And I know Charlie is Fairbanks, one of them, and some of the people from Nova, from Enbridge. And also I've got permission to use some of the slides from various organizations. So I've tried to put everything together that I can to share it. So now I'll get back to your question. And maybe the question was BCF. That's a good question. It stands for billion cubic feet.
Ooh, that is a lot. So we had two of those. What is BCF? So billion cubic feet.
Yeah,
so they're using feet instead of like meters.
Okay, I do have the numbers in metric cubic meters, and everybody kind of goes back and forth with these. And it's funny how people do that, right? Because officially we're supposed to use the metric units, and a lot of people understand the BCF much easier. So I actually tried to do that once. I tried to figure out how many sky domes we could fill with a BCF of natural gas, but I've forgotten. I'm getting old. I've forgotten that number. But that's what it stands for. And if you divide, if you want, I can give you certainly the. I've got it here. I can give you the numbers that are in cubic meters as well.
I would love to hear that, but I don't need to hear it right now. But piggybacking off of that metric versus imperial, one of our participants asked, is there comparable storage based on the images that you showed in Michigan?
Yes, there is a little bit of it. I know there's some cavern storage, and I know there is some reservoir storage, but it's not as, what do I call it? I can't get the numbers on it as readily. So I know it exists there. There's actually a school that they put on in Michigan where they actually require you to have requirements for storage. But I'm not up to date on the numbers, but I do know they have some. It is not as regulated as it is here. And a lot of them actually use our CSA Z341 standard because there's not too many other standards available. And I know it's used internationally, but I don't have the numbers exactly here. And but I think it's available at the Michigan oil and gas site.
Okay, so we have another question that is, Is there cavern storage in other provinces? So we have a wide audience tonight. We have people from all over. Is there cavern storage, say, out west, or is this a unique to Southwestern Ontario phenomenon?
That was one of the slides I cut out from my presentation. So there is in Alberta, primarily in Fort Saskatchewan area. There is in Saskatchewan. They actually store natural gas in some of those caverns. And they developed 3 caverns in Nova Scotia, but they were not used for natural gas storage. So they have developed them, but if I get a second, I'll pull the other presentation out and actually, I can actually show you because I did take that one out of my numbers.
Well, I'm glad we had the question.
No, that's good. That's a very good question. And I struggle because I'm trying to take a complex topic. I'm trying to simplify it and saying, okay, listen, I've already got 59 slides. I have a very short time to do it. How am I going to cover that?
Yeah. So we have another question.
If you want, if whoever's asked that question, send me an email and I'll send you a copy of it.
Yeah. So we have another question. Why is there so much storage in Lambton? And from Stan. So he wants to know why Lambton and why not anywhere else?
Really good question. And I think if I go back to the presentation, let me just go back here. Why, Sarni, I know I'm not somewhere else. Just hold on here. You see this, these 2 pictures in here, right? First thing is you want this kind of a storage reservoir. There's a Pinnacle Reef, and they occur primarily in the Lambton County. This is for the natural gas storage. So when you look at where they're located in the subsurface, this is kind of a map in the subsurface of where they exist. So this is 600 meters below ground, and they happen to occur on this Pinnacle Reef belt. So essentially, this happens to be a really good area where they occur. So your geology has to be right for you to have that storage. So I think it's one of those blessings that happened a long time ago, and you just have to be lucky to be sitting on top of it. Good question.
So to go a piggyback on that, our Pinnacle, how do you identify Pinnacle Reefs? Are you using 3D seismic, or are you using seismic reflection surveys?
Obviously a geologist question, but typically they would use, the technologies. What they're talking about, maybe if I can simplify the question, is you do the seismic surveys based on putting charges at the surface and seeing how they reflect. And what you try to do is you try to measure, see where these things are potentially existing. So there's different technologies of doing that. There's a 3D seismics. You can get a lot more exotic with what you try to interpret. But what you try to do is use some kind of a technology where you're trying to bounce the sound waves off, and you're trying to collect that data to see if these type of things actually exist in the subsurface in a 3-dimensional way. So sometimes, you just have to be in the right area. And a lot of people are looking for this, right? And the technology is becoming better. So people can know, every time, first thing is you have to be able to find it, right? Yeah, and then even if you find it, you may think it's a good reef, but you don't really know until you drill it whether it's great reef or not, right? So, you use the 3D seismics to give you the best measure of where this reef likely is, but then you may actually have to go in and drill a well to find out how good it is.
Now, to piggyback off on that, if you're looking for 3D, we also have at the Oil Museum of Canada, produced by Oil, Gas and Salt Resource Library, a virtual reality where you can fly down and see the actual reef structures and the geologic formations. So you can see the fault lines. There are fault lines in Lambton County, and you can see the reefs and the pinnacles, and it'll be explained. And a lot of the resources that we have are provided by Oil, Gas and Salt Resource Library. They're the ones that shared some of those core samples with us, and they are great partners. Piggybacking is Mark, who wants to know, is there a geologic event that led to the pinnacles?
Well, not one particular event, but if you go back to the pinnacles, you can quite often see how they're formed, okay? There's quite often the formation of these, you almost want to go back to the to the reefs that you see in Australia, like these, where you got the marine creatures growing. You look for a structure that deposited, that actually had some porosity, permeability in it. Then it got deposited in a particular fashion so that the gas actually got trapped in there. So, when you look for these things, they've been deposited, I'm not sure exactly how many millions, but many, many, back in the Silurian age.
Yeah,
And
so we're looking at about 500 million, I believe.
some of it, yes, but yes. And, so there was oceans, they had to go in a certain way. You had to have a certain type of things happen, and they had to develop in a certain way. So they actually grew in a certain mound, certain way that they actually made them a pinnacle reef.
We have another question from Douglas Beatty. He wants to know, Sifto salt solution mined salt in what is now Centennial Park in Sarnia next to the St. Clair River for many decades. Have the caverns created ever been logged or monitored, or are they just full of water right now? The ones that are sitting under, I think it's Centennial in Sarnia.
Yeah, okay. So they've actually done a study, and there was a lot of small solution mining operations that took place, Sarnia, Courtright. People would go in and they would drill a well, and they would wash out the salt, similar to what I said in that what I showed in that presentation. But quite often when they did that, the salt around of it would cave in, and they only had a limited amount of capacity. Like there's some impurities in there that would cause this thing to collapse. The good thing is that the structure down there is strong enough that it would support it. It's when you take away a lot of that salt, and then you don't have the sporting cap rock above it, then you can have problems. But as far as the ones that are in Centennial Park, there's quite a number of them. There's a report done by Patrick Chance, the Chance report, where they've actually gone through and looked at all of the solution mining operations and have reports available on that. So I'm not particularly sure exactly what happened on the Centennial site in terms of the abandonment, but certainly there's information available, as you've indicated, at the Oil, Gas, and Salt Resources Library.
Pat Marisso wants to know, how difficult is it to store hydrogen in a cavern?
That's a really good question. It's been done in other jurisdictions, and I'm actually involved in the Canadian Standard Association Committee. We're looking at this right now. Hydrogen is a different molecule in the sense of compared to methane, compared to ethane, these type of things. It's a much smaller molecule. It actually has more different corrosion type of things. And there's a lot more pressures that are involved in order for storage. So you have to look at this as a whole picture. We're looking at it, and we're assessing it. But you get the hydrogen embrittlement. You got a lot of different things you really have to consider before you do it. But there are people studying this right now, and it's been done, I think, in Europe, and I think in one of the places in the US right now.
We've got a couple more questions, and then I think we'll be, so from BL, it says, so from storage, how does it get into the system for consumption? Is it scheduled or is it ad hoc? So we have it in the system with the brine, with our displacement method, but how does it go from storage to consumption?
Okay, so this is for the salt caverns. Normally they're hooked up to the processes or to the pipeline for deliveries. So in a plant, in a petrochemical plant, you would use your cavern for storage. For example, if you're making ethylene, you need to send so much to your other customers that the rest of it goes into storage. If you needed more product, then you would take it out of the storage and supply to the customers. So it goes through pipelines, and there's a huge complex network of pipelines within the Sarnia. Like I know, there's most of these refineries are interconnected, where you can take your product, ship it to somebody else, or vice versa. And quite often, some of the companies specialize in different things. Like some of them make polyethylene, so they need the ethylene. Somebody else produces it, but they need to take it at a certain stage, and they need it regularly. So storage actually comes in really handy. Even if your plant is shut down, you can still continue to provide your customers.
So one last question. An anonymous attendee wants to know if you worked for Polysar or Nova in the 1980s. I think it's a former colleague.
Yeah, I actually had 14 business cards and 8 years working in the same company. So at that time, it went from Petrosar to Polysar to different divisions thereof. And then it became Nova and also Nova Chemicals. So it actually went through a number of name changes. But the plant is very similar. I mean, I know it's going through a big upgrade right now, but certainly I was involved quite a bit with the Nova Chemicals, and they're quite involved with the cavern storage as well.
So one last question. Has anyone studied the historical caverns from the late 1800s, early 1900s from early brine operations in the small towns between Goderich and in Sarnia?
As I said before, this is only for my topic, but I'm aware of that report done by Patrick Chance, where they have looked at it. And generally speaking, it depends on how the operation was conducted. There are many operations, and I was actually surprised when I read that report to find out that, the number, like I said, even in the Sarnia area, and Yuba Centennial Park, I know there was an operation in Courtright. There's quite a number of different places up around Goderich as well. So I think when you go back to the history of it, in Goderich, they were looking for oil and they actually found salt, and they were really happy with that, right? That was a great resource at the time. So there's a lot of history and a lot of these type of things, and certainly, there is information available. And if you go back even to the 1913, I think there's a lot of geological reports as well that kind of highlight what happened then. So
yeah, we are making partnerships with sister museums, especially in Goderich and in a couple of other sites further north where they were involved in shale mining for oil and gas. So building retort furnaces to get the kerosene out, and a couple of the solution mining places. But friends, thank you for all your questions. We are very excited to have Jug with us. I can't wait to see other things that are coming. We do have future presentations that will be coming out in February, where we'll be talking to the Canadian Energy Museum about what it was like for an industry to move from Southwestern Ontario to Alberta, and what was that start for that Alberta industry. But thank you so much for everybody for joining us. Thank you on behalf of the Oil Museum of Canada. Thank you so much, Jug, for putting all of this hard work and effort into this presentation. It has been enlightening, thrilling, and lots of fun questions. I learned a lot.
thank you.
Okay, so we'll stop recording.